Emilie Ferreira, 1977, Test Corrections, Part 1. So for number 25, for letter C, you need to find speed as a function of time. So you know that speed is the integral of acceleration in respect to time. And driving that, it would be dv over dt equals, you already found your acceleration in part B, which is negative kv over m. So you use that. And then using your differential equation, you take the integral of both sides, and your bounds are from vi to vf because it's asking for the general speed as a function of time t. So you need both bounds, and then 1 over v dv equals negative k over m dt. Now, integrating that becomes ln vf minus ln vi equals negative km t, because you could take the negative km out because it was a constant, and integral of dt is simply d, or t, sorry. And simplifying that more, you get that. And then the final answer, once you take more, so then you have the vf equals e to the negative k m t times vi. So then you just put the vi here to make it look better. And that is your total, that is your final speed, or the speed. And now for D, you need to find, this is 25. Part D, you need to find the total distance. So you know that the distance is the integral of velocity. So you use the velocity that you found in part C to do that. So S equals integral of VIE negative K M T. And now it's TI because you go from initial time to infinite time because it's asking for the total distance. That's why I use infinity. And then once you do all that out, you come down to S equals 0. It tells you that the initial time is 0, and it also, when you have e to the infinity or anything to the infinity, equals 0. So S equals 0 plus m over k, because you took the integral of that, e to the negative k over m ti, because you plugged in ti for that. But since ti equals 0, it's just e to the 0, which is 1, so it just becomes s equals, so you can just get rid of that, so s equals, oh, I'm sorry, it was supposed to be, you still had the vi, so s equals vi times m over k, and that is d, that is total distance. So now for 26, when you draw vectors that represent the cylinder, here's the cylinder, you need force of friction because it's sliding, and that is equal to ma. And then force of gravity, because gravity is pulling it down, which is mg. Normal force opposes that, but it's equal to it. And because it's on the ground, that's why there's normal force. And then force T, tension, that'll be, or it tells you that there's directed vertically upward with T, a force of T, and that gives you that is 0.6. And you know that normal force is 0.4 mg because you need something to counteract that 0.6 to make it 1, because it needs to pull that and work with that. So that's A. B, when you're determining the linear acceleration of the thing, you know that force of friction equals ma, and you know that force of friction is mu Fn equals ma, and you know that force of Fn is 0.4 mg, because we already found that, and I gave you that mu was 0.5 times 0.4 mg equals ma. When you swing m over, they cancel, so then that becomes 0.5 times 0.4 times 9.8 equals A. And if you use just simply 10 for that, it will equal 2. And that is the linear acceleration. For C, they want you to find the angular acceleration. And you know that the angular acceleration will be the force of the force of torque. Angular acceleration is torque over I. So, and you know that the torque, the two forces of torque are the forces that don't come from the center, because you need to incorporate the radius, and at the center of the circle the radius is 0. So, for example, normal force and force of gravity will not be included. So it'll just be equals torque of friction plus torque of the T force. So then that would be R times, and they gave you force of friction, which was they gave you force of friction, which was 0.4, and they said that, okay, yeah, force of friction is mu Fn, sorry. And you already found that to be, or whatever, so then you do that minus R times, because you have to do the radius times, and T force, which was 0.6 that they gave you. And then that is all over, you know, that I equals 1/2 mr squared. And this, the two torques are over 1/2 mr squared. Okay. And that is C. And you know that they don't equal each other. You know that and for D, you know that that is not true. That is true. You know that the angular acceleration and the linear acceleration do not equal each other, because in this case, the cylinder is slipping. If the cylinder had not been slipping, this equation would be true, but since it is slipping, it's not.